today we're tackling this idea of intuition versus logic, how those two, seemingly opposite forces work together in our brains, and how they're showing up in the world of AI, especially after you sent me those excerpts from Artificial Empathy.
Oh, yeah. Chapter 8 on dual processes really gets you thinking.
Right. Like, are we just logic machines, or is there something more to it, something more intuitive, driving our choices?
Yeah, it's a fascinating question.
And you know what's really wild? AI might actually hold some clues, like with AlphaGo Zero. But first, let's back up. The book starts with this concept of dual process models, basically saying our brains have these two different modes.
Right. It's like having two different operating systems running at the same time. So we have system 1, which is all about speed, instinct, like that feeling when you swerve to avoid something in the road before you even really know what's happening.
Oh, wow, yeah.
Exactly.
And then there's system 2,
Yeah.
which is more deliberate and analytical, like when you're trying to solve a tough Sudoku puzzle or plan a trip. So are these two systems always, like, fighting each other in our heads? Or do they actually work together?
Well, that's where things get really interesting. The book actually suggests that human cognition originally started with just one system, the intuitive one.
Hold on, so you're saying that all this complex stuff like logic and language actually came from this more basic intuitive system?
That's the idea. It's almost like our brains develop this virtual machine on top of this older intuitive system, and that virtual machine is what lets us do all that logical thinking.
Okay, that is mind-blowing. But how does this all connect to AI? Are we trying to build machines that can use both of these systems, the intuition and the deep thinking?
That's the big question, isn't it? And AlphaGo Zero really gets to the heart of it. You know, this AI system that learned to play Go, which is an incredibly complex game just by playing against itself. No human input, no pre-programmed strategies, just the rules of the game and a lot of practice.
So how did it get so good? I mean, superhuman level good without any help from us.
Well, it really shows how powerful it can be when intuitive and rational processes work together. AlphaGo Zero uses something called model-free reinforcement learning, which is basically like trial and error. It's like our intuitive system, learning by doing, building habits from experience. But it also uses model-based reinforcement learning, and that's more like our rational planning side.
So is it fair to say that AlphaGo Zero is basically showing us that these two systems can come together, like a fusion of intuition and logic that leads to this incredible level of mastery?
Exactly. It's almost like it's bridging this gap between gut feelings and logic. It's really showcasing how powerful it can be to combine these two seemingly different ways of thinking.
That really makes you think about how we define intelligence.
Yeah.
It's not just logic, right? It's this ability to adapt and be creative, to learn from what you've done and use that in new situations.
Absolutely. And this brings us to another fascinating concept from the book. Code duality. The idea that digital information, well, it's not just something humans invented, it's part of life itself.
Wait, are you saying DNA is basically a digital code?
Exactly. DNA stores information digitally, just like the code that runs our computers. And our bodies seamlessly combine this digital information with the analog world of chemistry and physics. Our brains might be doing something similar.
So are you saying there's like a digital part of our brains? Some hidden code controlling our thoughts and actions?
Now, that's a fascinating possibility.
I'm starting to see how these ideas connect. Our brains blending digital and analog processes, just like biology has been doing for, well, forever. Maybe AI can tap into those same principles to become even more sophisticated.
You're catching on quickly. And that brings us to this idea of constraint closure.
Constraint closure. Okay, I need you to unpack that one for me.
So imagine a network of processes, all interconnected, each one influencing and being influenced by the others. The output of one becomes the input for another, creating this continuous loop of interaction and adaptation.
So it's not just a straight line, but more of a circular dance, where everything contributes to the overall meaning and how the system works.
Precisely. And this applies to all sorts of things: biological cells, ecosystems, and potentially even the human brain.
So how does this constraint closure idea show up in AI?
Well, think about deep learning. We give these neural networks tons of data, and they learn to recognize patterns and make predictions. But things get really interesting when we introduce feedback loops. This allows the AI to learn from what it does and get better.
So it's like we're giving AI the ability to self-reflect, analyze its own mistakes, and adjust accordingly.
Exactly. That ability to self-correct and continuously adapt, that's a key part of intelligent systems, both biological and artificial.
Wow, okay. So we've talked about a lot. Dual process models, the merging of intuition and logic, this wild idea of code duality, and now constraint closure. It's a lot to process. But before we go further, is there one big takeaway you want to highlight for our listeners?
You know, what's really fascinating is how these concepts are changing how we think about intelligence. It's not just about logic and reasoning anymore. It's about how different systems interact, how we adapt and learn from experiences, and how meaning comes from these intricate networks of relationships.
And the really exciting part is that AI is starting to demonstrate these principles. It's moving beyond those simple rule-based systems, embracing intuition, self-learning, and creating meaning through this idea of constraint closure.
We're on the edge of a major shift in how we understand intelligence, and AI is a huge part of that. It really is amazing to think about.
Hmm.
AI may be revealing these core principles of intelligence that we're only beginning to grasp.
It feels like we're on the edge of something truly revolutionary. But I'm still kind of stuck on this constraint closure thing. How does that actually work in our brains?
Well, you can think of your brain as this massive parallel constraint satisfaction machine. You're constantly being bombarded with sensory information, and your brain has to make sense of it all, right? It needs to find patterns and connections to help you navigate the world.
So it's like our brains are always solving puzzles, trying to put all the pieces together.
Exactly. And each piece of information, each constraint, helps shape the overall solution. It's not just processing data, it's about understanding how those pieces of data relate to each other, building a model of the world that makes sense.
And is that where this semantic closure idea comes in? That meaning comes from these closed networks of relationships?
Exactly. Meaning doesn't just exist on its own. It emerges from the connections and constraints within the system. Think about language, for instance. The meaning of a word isn't inherent in the word itself, it's in how it connects to other words, our experiences, and the world around us.
So it's like a word only has meaning when it's part of this larger web of relationships, a sort of linguistic ecosystem where everything is connected.
Precisely. And this principle might apply to the internal representations that AI systems create. These representations may not be meaningful on their own, but when connected in a closed loop through this constraint closure, they could give rise to something like understanding, like meaning emerging within the AI.
Wow, that's a pretty deep thought. So intelligence isn't just about processing information. It's about creating meaning from that information and understanding the world in a way that lets us act in it.
And that's where the similarities between how our brains work and how AI works become really interesting. If AI systems can start creating their own models of the world, shaped by constraints and feedback loops, well, they might be capable of understanding things at a much deeper level than we've ever seen before.
But how do we even begin to design AI systems that can do this, achieve this semantic closure, and create meaning from data?
Well, the book mentions some cool examples like DeepCoder, the system from Microsoft that can actually write computer programs. DeepCoder uses something called a domain-specific language. It's kind of like a limited vocabulary of programming concepts. And it uses deep learning to predict which combinations of those concepts will get the desired outcome. It's basically learning to think like a programmer without having to be programmed every step of the way.
So it's not just copying code, it's actually coming up with new solutions, new ways to solve problems that even human programmers might not think of.
That's the amazing part. And it shows the power of constraint closure. By working within the limits of that domain-specific language, DeepCoder can explore all these different possibilities and find creative and effective solutions.
So that's really impressive. It's like AI isn't just automating tasks, it's boosting our own creativity, helping us explore new ideas and find solutions we might never have thought of on our own.
Exactly. And DeepCoder is just one example. There are tons of AI systems being developed that are inspired by constraint closure and semantic closure.
So it seems like we're headed towards a future where AI systems aren't just tools but collaborators, partners in exploration and discovery. But if they're generating their own models of the world, their own understanding of meaning, does that mean they're developing some form of consciousness?
Now, that's a question philosophers and scientists have been wrestling with for ages, and it's one we're really starting to grapple with as AI gets more advanced. But one thing's for sure, as AI systems become more sophisticated, they're making us rethink what it means to be intelligent, to be conscious, to be human.
It really is a mind-blowing time to be alive, to see technology and our understanding of ourselves coming together like this. But let's talk about the practical side of things. Are there any specific takeaways from artificial empathy that, say, AI researchers or developers could actually use in their work?
Well, one of the big ones is this idea of moving beyond just feeding AI huge amounts of data. We need to think about how to design systems that can generate their own data. like building their own understanding of the world through exploring and interacting with it.
That's a big shift. It's like going from passive learning to active learning, from students to explorers. But is there any evidence it's even possible?
Oh, definitely. AlphaGo Zero, remember? With its self-play mechanism, it wasn't just learning from games played by humans. It was creating its own data, its own understanding of Go through exploration. And that's what led to those really innovative, unexpected strategies.
It's like giving AI the freedom to learn and grow on its own, you know?
Yeah.
Maybe even discovering things that we humans might never have thought of. Are there other areas of research where people are looking at AI as an explorer like this?
Absolutely. There's a lot of excitement around AI systems that can understand cause and effect. Right now, AI is really good at spotting patterns, but it has trouble understanding the why behind those patterns. Knowing something happens is one thing, but understanding what made it happen is a whole other level of intelligence.
Imagine if we could create AI that really gets causality. That would be huge. Like, think about tackling these big societal problems like poverty or climate change. Understanding the root causes would completely change how we approach finding solutions.
Exactly. And the applications are endless. Think about more effective education systems, personalized medicine, even new forms of art and music, all driven by AI that understands cause and effect. This journey into AI isn't just about technology. It's about understanding the very core of what it means to be intelligent, to be creative, to be alive. And the deeper we go, the more we're likely to uncover these profound connections between the human mind and the machines we're building.
This has been an amazing deep dive. We started with dual process models, then the fusion of intuition and logic, and those mind-bending ideas of code duality and constraint closure. And we've seen how AI isn't just copying how we think, but maybe showing us completely new ways to understand intelligence itself.
And as we keep moving forward, the most important thing is this. Don't be afraid to really engage with these ideas. Ask questions, explore. AI is a reflection of us, of our own intelligence and creativity. By understanding AI, we're actually gaining a deeper understanding of our own minds and our place in the universe.